And hello again, student business people. Professor Peter Gregory here with a video for a solution for the Connect homework. This is not the same as the Chapter 310 problem out of the back of the chapter, but this is the Connect homework that we had. This is problem 310. I've made other videos that I've published out there for you to take a look at, and I went over this in both sections of the course right now. Then there was some finer detail about this that I wanted to go over so that I'm going to try to, within 20 minutes, get through this fairly quickly. I want to go over the finance, what the real finance of net present value really means. I think that sticking on this problem and everybody learning it is a really important thing. This is a pretty powerful analysis of any project that you might be given when you walk in on a job. Okay, so let's try to talk about the finances a little bit. I'm going to go over here and draw some pictures. All right. So what we have is a number of future cash flows that happen. I want to work forward and backward, okay, because it works both ways. All right. So we have a function in Excel, formula in Excel called the present value, but let's talk about what the present value actually means. Okay. So if you have $100 and you put it into the bank and the rate is 12% per year and it gets compounded every month to all the way out to month 12. Okay. What we're going to do is we're going to look at the value as this thing increases. We're not going to add any money back into this. We put in $100 and we're going to wait for the end of the year and see what comes out. What's the present value of these future cash flows that happen? Okay, so how do we calculate that? All right, so we've already said that we have an interest rate of 12. So for any period that's a month, we could take the 12%, divide by 12 months, and that's going to be equal to 1%. Okay, then pick the number on purpose, obviously, right? Okay, so we have the present value that we put in there. The future value is what we're trying to calculate here. So we have the present value, and we're trying to find out what the future value of this is month by month. So when we put $100 in at the end of month one, it has accrued the benefit of the interest rate that we put it in there with. Okay, so it's basically going to be you're going to get your $100 plus $100 times the interest rate. Okay, so we're going to have the rate, okay, the rate by the period. And I'm being a little verbose here, so you don't forget that you're taking the annual rate, this rate is the annual rate, and dividing by the number of periods, which we already did. I just put that in as a reminder, okay? So if we look at that future value, we can factor this out as 100 times 1 plus the period rate, okay? And so for each subsequent month that we put it in there, it's obvious that we can take the amount that we started with. Now for month two, the entire amount is going to be this. And for month two, we're just going to take that entire amount and we're going to multiply it by 1 plus the rate of the period. And what does that give us? So the value at the end of month two is going to be 100 times 1 plus the rate squared, okay? So we're going to put a little cheat in here. We're going to remember that this is period 1 and 2 and all the way through, and this is going to be period 12, okay? So for all the periods as you come out here, for whatever period you're in, if we're measuring the value of this at the end of the month, okay, that we can tell by this simple equation we just figured out, there's not too much to it, that the value of our deposit is going to be 1 plus the rate raised to the 5th, okay? And this keeps accumulating. We're not putting any extra money into the account, and by the end of the account, we will have the value of it will be equal to 100 times 1 plus the rate to the 12th. Let's go run over. I'm going to cheat this really quickly down here. I'll add another sheet here, okay? And so we had our interest rate of 12%, and to do this correctly, I'm going to set up this cell as a percent. We want 2 decimal places. And I'm going to punch in there 12%. Okay, the number of periods is 12. Okay, and so we have period 1 or month 1, since we're going by months, month 2. Okay, we'll grab these and drag them all the way out to month 12. There we go. Okay, and let's run that equation in here. So our present value that we started with is going to be 100. Okay, this is the number of periods. And this is the discount rate, okay? The annual rate. That's the annual rate. So we have to remember to do something with that. So if we want to calculate that at any month, we can say that the value at any month is going to be equal to the present value times this thing called 1 plus the annual rate over the number of periods, like that. And I prefer to put parens around everything. I don't want to leave to risk the order or the precedence of operations in any equation. Okay, so we have the present value is C6 times 1 plus the rate we just calculated in here, right? And we're going to raise that to, I'm going to end up putting some numbers in here into what period we're in. Okay, so I'm going to hit, before I hit enter, let's see, what do I want to do? Everything look good? Actually, I want to use another set of parens so we make sure we know what the order is here. I want to raise that to this number. And if you really want to get crazy, you can put another set of parens around it to make sure that you're all multiplying it correctly. Okay, so this is going to equal our present value times, and we want to be careful with keeping things in parens so we have the order precedence of the operations set in this correctly. So we're going to use a whole bunch of parens here. Better safe than sorry. Okay, so we're going to take the present value times basically 1 plus the interest rate. So let's put that in 1 plus the interest rate divided by the number of periods. So you can stop and you can study this and make sure that you understand what it's about. And I'm going to use F3 here. I'm going to type in 1 for that, and suddenly things change. Okay, so you're going to notice that my solution down here for taking an investment and putting it in at a constant rate, you can start calculating this. So what I need to do is put in which period we're in. This is just an index for these equations that we use. Okay, hold down Control, and I want to grab all of these numbers, and I'm going to flood that with my favorite dark blue, which is something like that. Hit it with white text and bold it up. Okay, so there we go. Looks a little bit better there. All right. So what we see is the effect of compounding. Okay. So you put $100 in, it gets operated on for 1 month, then it gets operated on for another month. And what we're saying is that a bank on a deposit account will evaluate your interest at the end of every month. If you read the fine detail, you might get different banks doing different things. You have to look at the fine detail here, but I believe still 99% of deposit accounts are simple monthly compounding of interest. Okay. All right. So whenever you borrow money or lend money like that, you want to check the fine details and see what period they're using, how frequently they calculate the interest on that. So just to be really clean, to make that, center that up. This is way overkill for what I'm trying to show here, but some people might help them out a little bit. Okay, so if we go back, that's how you're going to calculate at 12% what you're going to make on that per year. You're going to end up with $112.68, right? It's not an even 12. It's because of the compounding here. Okay, so we have done the calculation of a present value at a certain interest out there at 12%. Okay. Now I'm going to show you how we work backwards for net present value. Now, instead of investing money and an operation of compounding interest happening to at every period here, we have some varying, and I'm going to look up here on the top. I'm going to work according to months because the previous example I used was according to months. And we're going to look at period 1, 2, 3, 4, 5, all the way through 12. Okay. But we're looking, let's say, at a year of cash flows that are coming in and they're random. Okay. So maybe we spend $1,000 or $10,000 the first month. And then for every month after that, we earn 1,000. Okay. I'm going to do something here. Okay. So the second month is going to be 1,000. And every month after that goes up by 1,000. Okay. So we made a little investment and we actually are getting these cash flows. This is a really good investment, probably, if we look at it by the time we're done. All right. So for every month, all the way out to the 12th month, we make an extra $1,000 on this. This is a really good investment, right? So by the time you get to the end, it's going to be $11,000. All right. So these are future cash flows. All right. Okay. So this is different. Now we're looking at varying cash flows out in the future. We have to bring each of these back in here. And we use this discount rate. The discount rate can be thought of as an interest rate you're borrowing to make this happen, okay? Or it can be thought of as inflation. And that most often is what you're going to look at here is the erosive value of inflation on things or effect of inflation on things. And the third thing is opportunity cost. You're going to look at another project, which maybe you have a better estimate of. Okay, so we have an estimate of what the other project will bring in as a percentage over time. Okay, so we're going to use that to compare about. In all cases, if our final net present value doesn't come out to be positive, then you're underwater. Your interest is eating you up, or your inflation's eating you up, or you're not beating the return on some other forecast on another project for opportunity cost. So to get at the root of the relationship between present value, we have present value and future value, okay, they work together all the time, okay? And so if we want to end up with, we've gone through the example here of getting the future value after a number of periods where we've had a deposit into a deposit account working at some interest rate, okay? And so that future value is going to be at any one of these periods is going to equal this initial value you had, this present value that you started with, times 1 plus the rate raised to the period you're interested to know what the value of that is. Okay? All we're doing when we're figuring out the calculation for present value is we're solving for it in this equation. So I'm going to swap this around a little bit, and it ends up being that the present value is equal to that future cash flow that we have, the future value, divided by 1 plus the rate raised to the p, whatever period you're in. That's as simple as it gets. So in class, we didn't exactly finish the high points. We didn't end on the major point with enough time to maybe let it all sink in. So this is one of our students that had sent me their file. I did a little bit of cleanup work on it, and now it's all better, or it's more complete in certain ways. And basically, the problem. Let me sit that down there. You can stop it and take a read of the problem that we're trying to solve. This is the problem. We've given some the primitives, we're given the givens here, and we have to make some calculations. We've given a schedule here about how it all works. Okay, all right. So I went over that in class, and I've reproduced all the accuracies into what I have got here, and it all works out. But let's go into the discussion about there's a fine point here that you can get trapped by Excel. Okay, and I'll show where that happens. In our problems, it starts out that we have some expenditures, and what the problems that we're covering implies that all these cash flows occur at the beginning of the period. Okay, they're right at the beginning of the period, not at the end of the period, and that's what I have to explain now. That's a little bit different. Okay, so if we flip back over to our sheet here, okay, it's not that something doesn't happen in the first period. It's just that we have to think about it a little bit differently. Instead of 10,000 spending it at the end of the first month, when you start a project, you don't really measure it that way. You start at the beginning at 0. Okay. So when we do the net present value and we think of it as the first expenditure taking place at the beginning of the first period. That's like the 0th period, okay? And instead of using the indices up here that we would use, 1 through 12, right, we would end up using 0 through 11, okay? So what we've done is really shifted the index of what period we're calculating these cash flows for. So instead of calculating that first 1,000 in against the second period, it really happened either at the beginning of the second period, if you want to think about it that way, or it ended at the end of the first period. Those are instantaneously like the same times. There's no time between the end of the first period and the beginning of the second period, right? So we end up, I think you can understand that we're going to have to calculate that for the first period. It's only been acted on by time and interest or inflation for, in this case, 30 days. We're doing months here, okay? The second payment in occurs after 60 days. So we're going to use the term 2 there. And then if you come all the way out, all the way here, instead of 12, we're going to have period 11, okay? So technically, we're going to get paid at the beginning of the last period. It's kind of interesting. And we're going to wait around for 30 days and nothing's going to happen at the end. So you have to think about that. It's either has a loose tail at the beginning or it has a loose tail at the beginning. The beginning or a loose tail at the end. All right, so here we go. All right, so that's the logic behind all this. So that when we calculate the present value of $10,000, the future value of it is instantaneously right now at the beginning, right? So we're going to have the cash flow from period 0, if we really want to think about it, divided by 1 plus the rate raised to the 0. And anything raised to the 0 is itself. And this just, fortunately, the math matches reality, is the time has not worked on our first cash flow yet of $10,000. The second cash flow will have worked on a period of a month. So the first cash flow at the end of month 1 is going to be divided by 1 plus the rate raised to the period, which is 1, which is just 1 plus that rate. If it were, in our case here, it would be 1.01, right? What are we saying? We're saying that because over time the effect of inflation, for instance, is working on our money, we have to discount. That's why they call it a discount rate, because we're discounting it. This number here, this denominator, is going to be greater than 1. It's going to be 1 plus a rate. Okay, so it's going to be greater than 1. Your cash flow is going to end up being smaller. Let's go back over and just skim through what's going on here, because I went through cell by cell really what's going on. But I want to describe that as something to watch out for with the Excel formula for NPV, okay? So what I did, I'm going to try to get this into a place I don't have to move it around anymore, okay? So the main summation in our Excel sheet from Q10, question 10 of chapter 3, you'll recognize some of these numbers, okay? So we're just dropping the net cash flows to this line. This grayed out line is just a simple summation of the negatives and the positives in there. All right. So if I click on that, you can see that I have a tiny, you can't really actually see it. There's a little negative minus sign in front of this parentheses of 1, 2, 3, 4, 5 terms. So those terms, if you look at, you correspond the cell references to what's going on here. The first one is development cost. That's a negative. Pilot testing, ramp up, marketing and support, and the production cost. Okay, so those are the first 5. They're all negative, and we just add our sales in there. Nothing too hard about that. Okay, we have a lot of things working already, right? We have that working there. Okay, and so this line is just summation of all the negatives and positives above there that are germane to the problem. And if we add all these numbers up, these cash flows add up to 10,500,000 approximately out here, right? The reason we look at that is now we want to go back and discount it. Now, if we do the simple discount method, okay, we would use this row of indexes for each of the periods. We would name period 1, 1. That means that things that we see here are occurring at the end of the period, okay? And that's why I have the present value using the period end. Okay, that's what the PE means, period end here, okay? So you can see that the first payment, if it ended at the end of the first period, got discounted a little bit by about $5,000 or $6,000 here. It's worth, in today's dollars, it's worth less than it would be in the future, okay? It's worth less in the future than it is now. All right. Okay. So I just recreated. You can take a look at what goes on up here. Stop the video and take a look at what's going on. But it's basically just the cash flow from the period C34 divided by 1 plus the rate. And that's a fancy calculation for the rate. How did we get that? We took the annual rate, we divided by 4, and we added it to 1. Okay. So that's the period rate. And we raised it to our little tricky index number up here at C22. That's how we got that. And then I grabbed that, and then because I had locked down the cells, I was able to drag it to the right. And it turns out that if you calculate it that way, so the first part of the problem says, let's calculate this all at an interest rate of 8%. Okay. And when we come down here is, okay, so if you remember, line or row 34 is unadjusted at all. This is just pure cash flow. And then now we're going to be calculating each of these cash flows at the end of the period. So if you look at this equation here and we work through it, it is simply the cash flow divided by, and that's 1 plus the rate. The annual rate divided by the number of periods is 4. So we have to get used to seeing things within these parentheses here. So that's one term there. We're taking all of that and we're raising it to whatever's in C22, which is the period here of 1. Okay, so that's saying that this is like how many periods did time have to work on this? How many periods did inflation have to work on this? And it was an entire period. We're looking at forward 30 days. And so the value in today's dollars of that future payment is only $326. When you're sending money out, you sent out a check for $333,000, but in today's dollars, it was only worth 326. Okay. All right. So the next month, it's kind of curious to watch. The next month that we had, we netted 333,000, but the effect of inflation on that for 2 months is another $6,000. We're now down to $320,000. Okay. And thusly, for each of these calculations, we're calculating it at 8% up here, right? That each of these is getting discounted for the compounding of inflation that many periods out. And when we add all that up, we come out with 8,336,000. What does that mean? That means that the total value of the project in hard dollars was 10,512. I'm sorry, let me say that again. Was 10,512. Right? But the effect of time, unless we make an adjustment on inflation with our customer who's paying us, is only worth 8,336,000. That means if you had a $10 million house picked out that you were going to take this cash and spend it on, when you get out here, they've been adjusting the price of the house against the inflation, and it would end up being more than $10 million. You could not afford it, in other words, right? If you had a $10 million house today, it means this would only give you $8 million toward it. That's what this means. It's like real money, okay? So it actually, in economic terms, has a big impact, okay? And so in companies of any size, if you're not watching the erosive value of something like, or the effect of inflation on that, you can end up being underwater if you're not careful. If you're not charging enough, if you don't have enough margin on these sales that you have, you might end up underwater. After all that work, you might end up making no money. So I always like to tease out what the real message is behind some of these things. Okay, now that's all fun and games and everything, but if you go to submit that, you're going to get a wrong answer in Connect. Why is that? It goes to the discussion that I had regarding that these problems, if you really look at it, you're going to spend that $333,000 right up at 0 time. All right, so you're actually like Q0. Okay, and that's why I produced the other line of indexes in here. Okay, if you look carefully, I inserted another line of indexes here that just reduced the period by 1. That's all you're looking at here. Instead of period 1, we look at period 0. I ran the same equation against this next present value using payment at the start of the period, or the cash flow at the start of the period, right? And it makes sense. It says 330. Now this new line, this row 34, is the $333,000 we paid out. We paid out in 0 time. So it was had no erosive effects of inflation on it. You have $333,000 you paid out at time zero. The next payment here of $333,000 had the effect of one real period. And see, now this column here, we're kind of looking at this taking place here at the beginning, not at the end, right? And so with that effect, you have $333,000. The effect of inflation worked on it for one period, and it ended up being $326,000. Okay. And for the next period, we're going to, instead of evaluating it as a third period, we're going to evaluate it as a second period, and you're going to end up with this number. Notice the difference in the lines of the payment at the end versus the payment at the start. Okay. Because the erosive effects of inflation only worked on this a period less, you can see that the numbers are larger, okay? So this row here had an extra period of erosive inflation applied to it than this one, okay? It just is the way it is, okay? That's the definition of the convention of the problems here, okay? So we went through and we drop in all these numbers, okay? So I carried these all the way through. I just copied that cell. Once I got this cell figured out, I locked down the cells I didn't want to change, and I just dragged it across. And then when you get this, you get 8,500,000. That looks good. That looks good. That should be taken by the system. The system should accept that. Okay. All right. So now let's work out how to do this in Excel. Now you see this little simple NPV. Oh, it looks like such an easy formula out of Excel to use. So here's the actual formula. Okay. Actually, this is an answer. I don't know where that came from. So let's do the formula here. It's going to be NPV of they want the rate before the first comma. So I'm going to ooch up a little bit here, grab our rate, divide it by 4/4. Always remember to do that. That's the downfall of many, okay? And then I'm going to grab our straight up payments. These are the unadjusted payments, cash flows from the future that we got. And I'm going to close that out, hit enter. And now we get the same number that we had that was sitting there, but instead of a hard-coded number, if I look in that cell before I just did that, there was just a number in there, hard-coded number that got borrowed from somewhere. But now I just put the formula in there, and that's the number. It picks up the wrong value. So over here on the right, you can tell the way that the NPV works is it just evaluates everything at the end of the period. You can't throw a switch in the NPV formula like you can in some other Excel to tell it to think about this a little bit differently. So to get the correct answer, you should be able to figure this out, but I'm going to tell you. All right. So to get the real NPV, let's put the NPV at the period start. Okay. So we have to make an adjustment here. It's going to look awfully like the other one, right? So let's see. I'm going to take this and I'm going to drag this down. I'm going to actually lock that in first. That's what I'm doing. And I want that sum to be the same. So I am going I'm going to hit F4 again. I want to lock those in before I drag this down. So I grab this. This number shouldn't change. Whoops. Control Z. Okay. Copied it too many times. Copy that down. It comes out as the right number. Now we're going to fix this. Okay. So if you come up here, what we really want to do is we don't want to start at column C. We want to start at column D. We want to start 1 over out to R34. Okay, the rate all stays the same. Okay, all I wanted to do was avoid using the first element here. So we're doing the NPV using Excel. Hit enter, right? And it comes out as 8,836,000 here. And what we have to do is we can't forget about that first term. And that first term, we're going to add, it's a negative number because it's red here. Okay. So we have to add that back in again. That's how we get the NPV formula to work the way that we did it using primitives and the long method. Okay. And so it's a well-known feature about Excel that you have to watch whether you're starting at the beginning or the end, or you're counting for the beginning or the end of a term. And so our book and our problems think in terms of starting right at the beginning there with an outflow with some kind of expenditure. That's really the story of what this is all about. Now, I will just show something here. So there's a little example to take this. We solved part A of the problem, and part B had something to do, and I'm not even looking at the problem right now. It had something to do with evaluating this at other discount rates. Okay, so you can do it the way that is shown here. Okay, you can create a new part of the table here. And that's great because now it's all explicit. Okay, so we punched in 9, 10, and 11%, and we calculated out what the present value of those future cash flows are if the rate were 9, 10, or 11. Okay, so now I've made adjustments to this. Okay, so I've adjusted this to make the calculations at the beginning of the period. Okay, and so these numbers should be fairly accurate, okay? But it's really a matter of method, style, or something else. I don't know what else you want to talk about or call it here. But the way we set up the problem from the beginning was that we used a nice little table up here, okay? And so if the system is asking you to punch in 9, 10, and 11%, another way to do that is a dynamic effect here is because we've punched in the formulas carefully here, we can come back up and we can do a sensitivity analysis up here. So where we have 8%, you can punch in 9. You'll see the ripple. If you notice in the video that all these numbers rippled, let's see if we're getting the same numbers. So the numbers that we want is really, this is the one that I'm going to highlight with a different color now so I can find it more easily with my eyes. And so let's paint that with a little bit of a, not a glaring yellow, but a little more muted yellow there. Okay, so it's a little bit more muted. Okay, so this is the corrected line for the beginning of the periods that we have. 8 mil, 283,000. I punched in 9% up here. Here's the explicit line that calculated the same thing. It came out the same. Okay, so things look good. All right, so we're just calculating the same thing two different ways. So I can come back up here, I can punch in 10, because all these cells that we have refer to this cell, or the other computation in the middle here. When I hit that, we'll have the ripple effect again, and that 8 mil 69,000 shows up here where we have the 10% calculated. And who wants to guess what happens if I punch in 11 here? Okay, get the ripple effect. All these rows change because they were dependent on this cell up here. And we get 7 mil 862,000. Okay, so obviously what happens if we consider this inflation, as inflation is going edging up here, in future dollars, it's worth less and less. And let's say you do want to buy a house with this, a $10 million house. So it all looked good to begin with. But as soon as we patch in inflation, as it increases, we can buy less and less of a house in the future if they adjust the price up for inflation. Okay. So in houses move in big numbers. You know, if nobody's interested, they'll drop the price and everything. So it's not tightly coupled to inflation. It's really based on what the buyer is going to pay anyway. But if it did, if you want to think about something else, let's say you want to try to make money with this project and you need $10 million for your next project. That might be a better way to think about this. That most of the prices on your next project will probably float with inflation. They'll float up, they'll be increased over time. And by the time you get out there 4 years, you're only going to have $7 million in a period of 11% inflation. And the prices there will have risen up to something much greater than that. Okay, so that's how that works. Hopefully, this ended up a little bit longer than I thought it was going to end up, but hopefully it's helpful. It definitely is deserved because of the questions that I'm getting here as to how this all works. So you can actually push this into fast forward, or you can put this on high rate in YouTube, and you can also go back to the different parts, obviously, to go over them to get this down. Thanks very much, and I hope you get a good grade on your submissions in Connect.